Hi, welcome back to another episode of Algebra in Words video series. Today we're going to go over factoring, greatest common factor, and least common denominator, usually known as GCF and LCD. Alright, before we get started, just a reminder that everything that we're going to go over today, actually not everything, but some of which we're going over today, you can find in my book Algebra in Words on Amazon. The link is in the description box below, and specifically in the book I cover factoring between pages 25, actually more like 22 to 32. But I think in this video we're going to go over a little bit more than what I have in the book. So for starters, you're going to need to be basically expert at factoring from here on out going forward, because a lot of algebra involves factoring and reducing and simplification, and that all involves factoring in some way or another. So that's why I call this video Factoring GCF versus LCD. I'll get into a little bit later on why I call it GCF versus LCD. Basically, we're going to be comparing the two, both in the differences in their uses as well as how to find GCF versus LCD. Alright, and I'm going to broach the subject of that right now. So let's start with greatest common factor. Alright, greatest common factor. Notice, alright, I like to break down everything, every word, every element. Notice that this is called greatest common factor, not just common factor. Alright? And I have three examples on the board that we're going to, in a simplistic sense, kind of go over and relate to greatest common factor. So first of all, what is greatest common factor? Well, if you notice here, I have GCD. Sometimes when you first start out learning greatest common factor, you might learn it as GCD, greatest common divisor. Okay, what does that mean specifically? It's a greatest common factor that you can divide every term in a series, whether it's an expression or an equation. Alright, and you use greatest common factor by dividing that greatest common factor out of each term. Each term must have that greatest common factor amongst themselves. So I'll just erase this for now, but I wanted to make sure you get introduced to it in case you see GCD. It's the same thing as greatest common factor basically, but I'll show you how we use division with the factor. Alright, so I have three problems on the board. This is a trinomial. This is just adding two fractions, and this is also a trinomial. But let's look at this one first, okay? And there's a reason why I have these examples on the board. It's because there's mainly two reasons why and when you use greatest common factor. One of them is for factoring out a greatest common factor and basically simplifying an expression or an equation. When you simplify, it takes the biggest numbers out so that you have the smallest numbers to work with, and basically it just makes it easier. Alright, it is something that you generally have to do to get to the end of the problem anyway, but it's always encouraged to simplify it as much as possible anyway, because it does make it easier on you, and I think everybody likes it, an easier path to the end. Also, greatest common factor is used to reduce fractions, okay? As opposed to, what is least common denominator used for? So this greatest common factor is used for reducing fractions, whereas least common denominator is used for adding or subtracting fractions. That's one aspect where LCD is used. Alright, and I had fractions for both because I want you to see how greatest common factor and LCD do tie into fractions, but for different reasons. We'll go over them in a little more detail in a second. Let's look at this trinomial, okay? The goal is to always look for a greatest common factor, usually as the first step for any problem, whether it's an expression or an equation. Is there a greatest common factor in this? Well, I just put this up as an example to show that no, there's not a greatest common factor in that. This expression is already in its most reduced form. So that's why I have that up there, and we can just erase that. Let's go to this trinomial and ask, is there a greatest common factor among these terms? And the answer is yes. The greatest common factor of these terms would be 2x. Okay? As I said, that we call that the greatest common factor. It's also the greatest common divisor. Okay? Why? Because it's the greatest term or group of factors that you can divide out of each of these terms to simplify the entire expression. Okay? As we said, the GCF is 2x. So let's show factoring out the GCF by dividing 2x out. So I wrote each term divided by the GCF 2x. Okay? I will go over in its own video specifically how to reduce fractions with variables, the quotient rule for exponents, but I don't cover that in this video, so for now this is just for demonstration purposes. But long story short, when you divide the greatest common factor 2x out of each term, what do you get? Well, whenever you factor a greatest common factor out, you put the greatest common factor in the front, and then parentheses to show that you're multiplying this through each of the remaining terms after you've divided it out. So 2x cubed divided by 2x leaves x squared. 6x squared divided by 2x leaves 3x. And negative 4x divided by 2x leaves you with minus 2. Okay? So now you got to see how we started with this trinomial, found the GCF, which was 2x, divided it out of each term, moved it to the front, and put what was left or simplified in parentheses. Okay? If you wanted to check that to make sure that it's true, you could take this and distribute it back through to get to the beginning. Although if you were to do that, that would only be for checking, but normally in a problem you wouldn't do that because it would just reverse your stage in the problem. Alright? Also, usually you only show dividing of the greatest common factor in the beginning when you're learning, but usually once you get good enough at it, usually you or your teacher won't show the division. They'll just kind of skip this part and just go right to here. Alright, once you get good at it, you'll basically just jump right to here. But in the beginning, or anytime you have trouble, if you're confused, don't be afraid to write out these steps so that you can manually and show on your paper how you're actually dividing and removing out the GCF from each term. It can be helpful. Okay, so as I said, one use of GCF is simplifying an equation or an expression. Another form is reducing fractions, and you'll have a fair number of fractions throughout your algebra class. Alright? So let's look at 4 over 8. Can we reduce that fraction? Yes, we can reduce that fraction. What is the greatest common factor? The greatest common factor is 4, okay? And if you think of a little miniature dividing the top and bottom by the greatest common factor 4, write what the quotient would be of each one below. So 4 divided by GCF 4 would be 1, and 8 divided by GCF 4 would be 2. Alright? Now again, are you going to show the division each time? Probably not once you get good enough at it, and you might even be good enough at it already. As you may have seen in other videos, usually if you're reducing a fraction, you might say, how many times does 4 go into 4? Once. How many times does 4 go into 8? Twice. And notice we are left with 1/2. Okay? What about 6 over 12? Okay? I put the 4 over 8 and the 6 over 12 up for a reason. In this particular example, we're not doing the actual addition or subtraction of the fractions. We'll do that in the LCD. But the reason I use these is because, look at 4 over 8. We determined that 4 was the GCF. But could you have divided 2 out of 4 and 2 out of 8? Yes. Why? Because 2 is a common factor, but it's not the greatest common factor. So you always want to look for the greatest common factor so that you can reduce the fraction down to its most reduced or simplified form. Now, a question students sometimes ask is it wrong if you divide a fraction by its common factor but not the greatest? It's not wrong, but let's take a quick look. Let's look at 6 over 12. Okay, what is a common factor but not the greatest common factor? Let's say 3. So we can divide 6 by 3 and get 2, and 12 by 3 to get 4. But if we look at the 2 over 4, we still have a common factor of 2 in 2 over 4. All right, and that would be reduced down then to 1/2. But if we use the greatest common factor of 6, then we can get to the most reduced form quicker. Again, 1/2. So the point that I wanted to make about common factor and greatest common factor is it wrong to find and factor out a common factor? No. If you do, you should always keep looking to see if there's another common factor, because you should still try to reduce it down to the most reduced form. It just might take a couple extra steps. But you should always get in the practice of finding the greatest common factor. That was really my only point on that. Okay, what about least common denominator? So we're pretty much done with that. What about least common denominator? All right. What is least common denominator most used for? Well, it's usually most used for, there's a few different type of times when you would use least common denominator. A main one is for adding and subtracting fractions. Alright, so I have a problem up which is 1 over 10x squared plus 1 over 15x, okay? And if you notice here, I say LCM. What's LCM? The M actually stands for multiple, alright? When we deal with any terms and you want to, here's my point. When you start off learning it, you might start off learning it as a least common multiple. They might give you two terms, say 10x squared and 15x, and say what is the least common multiple. But truthfully, anytime that you're learning least common multiple, it's really to learn it for denominators, least common denominator. So that's my point. Don't get confused if you see LCM. I'll teach you how to find LCM later in the video. But basically, it's to do with fractions, specifically for denominators, least common denominators. Alright, so anyway, let's look at this problem. And we want to find the least common denominator of 10x squared and 15x. So I factored the LCD out for you already. We're going to do prime factorization later in this video. But for now, I wrote it out. Okay, and basically, again, I'll teach this in a minute, but the least common denominator we determined is 30x squared. Okay, so what do you do with the least common denominator, 30x squared? What does it mean? Well, here's what you have to do with it. I always recommend to you and my students that you write out the LCD both as factors and the product of its factors. That way you can use it as a reference, because you need to know how to functionally use LCD. I want you to compare this denominator, 10x squared, with 30x squared. And this is what you should be asking yourself. What's the missing factor between 10x squared and 30x squared, of which you can multiply the 10x squared by to get 30x squared? And the answer to that for this one is 3. So we're going to multiply the top and bottom of that fraction by 3. Why do we do that? Because remember, using LCD is what you use to add and subtract fractions that are not currently alike, but to make them alike so that you can add or subtract the like fractions. All right? remember, whatever you multiply times the bottom, you multiply the top by, because any number over itself is 1, and it maintains the fractional value of the fraction. Alright, so let's apply that same method to this denominator, 15x. Compare 15x to 30x squared. And again, ask yourself, what is the missing factor? What do you have to multiply 15x by to get 30x squared? And the answer in that case is 2x. So we're going to multiply the top and bottom by 2x. Alright? So that's done, but now let's move on to doing the actual multiplication and converting them into, their new denominators and like fractions. Alright? So what I'm going to do here is I'm going to write a fraction bar, and I'm going to write 30x squared, because that's where our final consolidated fraction and answer is going to be. But for now, in the line below, let's just write what we get when we multiply the top and bottom by the factors. 1 times 3 is 3, and 10x squared times 3 is 30x squared. Okay, bring down the plus. 1 times 2x is 2x in the top. 15x times 2x is again 30x squared in the bottom. Now you can see that these are now like fractions, because now they have a common denominator of 30x squared. And now we can add them. So we're going to add across the top 3 plus 2x. They happen to not be like terms, so we can't combine them, so we're just going to leave it. I'm going to squeeze it up here. 3 plus 2x. And that's the answer. So those are just two basic examples of how to use greatest common factor and least common denominator, and when to use greatest common factor and least common denominator. Alright? I'm going to erase this, and we're going to talk about this a little bit more in a second, where we're going to go over prime factorization. But before we do that, I want to make a couple points about just a few more commentary points on the difference between greatest common factor and least common denominator. If you notice, for greatest common factor is something that we always look for. It might be there, it might not be there, but it's something that we look for or we find. But we never create it. But in the case of least common denominator, sometimes we always look for it if we need to. Sometimes it will be there already, but sometimes it won't. When it's not, we create it. Okay, so notice the 2 points that I made there. For greatest common factor, it's something that you would look for only. If it's not there, you move on. It's simplified already. You don't create it. But for LCD, you look for it. If it's there, use it. If not, you have to create it. Alright, and I'm going to show you how to create it shortly, a little bit later in the video. Now also, for greatest common factor, again, the two main times that you would use them would be for reducing fractions. You'll get into fractions that deal with more variables later in algebra, as well as, and really this is the main use really, is reducing or simplifying an expression or an equation. But for least common denominator, there's actually a few more uses. One of the uses is for eliminating fractions, specifically when you're dealing with rational equations. I'll be doing a video on rational equations. Look for that in episode 136. And also in terms of another time that you use LCD especially is when you're reducing or simplifying complex rational expressions. And I'll be going over reducing complex rational expressions somewhere in video 124. Alright? You can find that in the link where I have each video listed. So I'm going to pause the video and I'm going to put something else on the board to go over. So what I put on the board here is, I'll explain this in a second. I put 54, 60, and 90. And here's what we're going to do. We're going to prime factorize these numbers. And then we're going to look for the greatest common factor and least common denominator amongst two of the numbers. Alright, and I'll put them up once we do the prime factorization. Alright, but just in case, as a quick refresher of prime factorizing, what does that mean? It means taking any number, it's usually a bigger number, and dividing it out into all of its prime factors so that each factor can no longer be divided. Alright? The way that you do that is you usually start from the smallest prime number and you keep trying to divide the number by it, and then the next highest prime factor, prime number, and the next highest, and so on, until you can't divide anymore. Okay, remember that a prime number is any number that can only be divided by itself or 1. Keep in mind that 1 is not considered a prime number, and also the opposite of a prime number is a composite number, or the opposite of a prime factor is a composite factor, which means it's a number that can continue to be factored into prime factors. So let's start with 54, alright? I'm guessing since you're already up to algebra, you've probably done factoring of numbers before, but still I'm going to go over it with you anyway. So start off with looking for any number you can divide it by, and then just split them up. So let's start with, say, 6 and 9. Alright, let's look at the 6. 6 can be broken up into factors of 2 and 3, and 9 can be split up into factors of 3 and 3. Okay? I'll come back to that in a second. Let's go to 60. You could say we could split up 60 as 6 and 10, and split up the 6 as 2 and 3, and the 10 as 2 and 5. And then let's look at the 90. You could say we could split the 90 by 9 and 10, and the 9 by 3 and 3, and the 10 by 2 and 5. So now these numbers are all prime factorized with their prime factors below. But now we're going to take the prime factors and we're going to write them in exponential form. Okay? Anytime that there's a repeat of a factor, we're going to put it together, consolidate it, and each time that it's multiplied by itself, we're just going to put that number of times as an exponent. That's what exponents are. So 2 is 1, and even though normally we don't have to write the power of 1, for now I'm going to. 2 to the 1, and we have 3 times 3 times 3. So it's 3 times. I'm going to write 3 to the power of 3, or cubed. Let's go to the next one. We have 2 twice, so we're going to write that as 2 squared. Then we have 3 once, and we have 5 once. And if we look at 90, we have 3 twice, 2 once, and 5 once. Alright, so now that we have those, I'm going to basically erase some stuff and put a couple problems on the board where we're going to get to use these. I erased the prime factorizations, I kept the factors, and I wrote 2 problems on the board. One where we're going to use greatest common factor, and one where we're going to use least common denominator, both dealing with 60 and 90. Alright, the 30, or the 54, we just aren't going to use yet. Maybe we'll use it in another example. But let's start with this, alright? We're going to, we're going to find the greatest common factor between 60 and 90, alright? Here's how to do that. Look at the factors of 60 and 90 in their exponential factor form. Now, because of the keyword common, for greatest common factor, I want you to find the factors between 60 and 90 that are only common, okay? Let's start with the 2 squared, or let's just start with 2, all right? Basically, you can only take a common factor when the base is in both, and you're going to take the lowest of the 2 exponents. So in this one we have 2, and in this one we have 2. Well, compare their exponents. The 1 is smaller than the exponent 2, so therefore we're going to take the 2 to the 1 because it's the smaller exponent. Okay, what about the base 3? This one has base 3 to the 1. This one has base 3 to the 2. We take the smaller 3 to the 1. And finally, what about 5? This is 5 to the 1. This is 5 to the 1. They're the same, so we're going to take 5 to the 1. Okay, you could leave them as factors if you want, but you could also multiply them together. And what is 2 times 3 times 5? It's 30. So the greatest common factor for 60 divided by 90 is 30. We'll use that in a second, but I want to stay focused on comparing and contrasting greatest common factor versus least common denominator. Now let's find the least common denominator of 60 and 90 for this problem, which is adding fractions where we have 60 and 90 as the denominators. Alright, so let me write LCD here. Now when we found greatest common factor, we looked for only the bases that were common, and we took their smaller of the exponents. But for LCD, it's kind of the opposite. We're going to take every possible factor that's there and take the highest of the exponents of everything. Let's start with base 2. Okay? Now, it doesn't matter if it has a common base 2. As long as there's a base 2 here, we take it. But if there's a common base of both, we take the higher of the exponents. So clearly the 2 is higher than the 1, so we're going to take 2 squared. Let's go on to 3. We have 3 to the 1 here. We're automatically going to take base 3, but if this has exponent 1 and this has base 3 exponent 2, we're going to take the higher. That would be 3 squared. And finally, if we look at the 5s, well, this one has 5, so we're automatically going to take 5 no matter what. But since they both have 5 and both have the same exponent, we're going to take the highest, which is 1. Okay, so if we multiply these together, 4 times 9 times 5, we get 180. Okay, so now that we have them, I'm just going to write that over here for now. So I can erase it here. Now that we found the LCD and GCF of both, now we'll move on to using them, okay? But again, let me just summarize because it's kind of one of the big points of the video in comparing these. To find GCF, we do the prime factorization, we put it in exponential form, and we only take the common bases and the smaller of the exponents. But for LCD, we take all possible factors, every possible base that's listed in any of the any of the numbers, and if there happens to be a repeat, we take the higher of the exponents. Okay, so back to the reduction of 60 over 90. We determined that the GCF was 30 because the product of these factors was 30. So how do you use GCF? Think of dividing